Okay, today I'd like to go over graphs of polar equations. There's a whole lot of stuff in this section about graphs of polar equations. We're gonna use all the things we know about sine and cosine and our unit circle and what values we're getting out of that. We need to know that kind of stuff. And then for a lot of the rest of it, we need to just have notes. So the good thing about right now is that you can use your notes on your homework and your quizzes and your tests. So just make sure that you have good notes for everything, or that you open up like the window it gives you when you open up, or you find some other ones that tell you about all these different kinds of graphs. It was all there in that original video. So I'm not going to explain all that, but I'm going to explain, where I got this stuff. So I've picked a variety of questions. So here's a question. Which of the following is the graph of the rose curve r equals 4 cosine of 2 theta? So I went back and looked at my rose curve notes, and r is a cosine in theta if we're using cosine. That's the rose curve equation we're going to use. So we figure out how many petals we have if n is even, which it is. In this problem, n is 2, and that's an even number. And if n is even, then we have 2 times n petals. So 2 times 2 is 4. We need 4 petals. So A does not have any petals. That is not really a rose curve. C has 3 petals, so it's not C. So it's B or D. Okay, it's one of those two. Now, the next thing we got to figure out is this a cosine? One of these is cosine. One of these is 4 cosine 2n, and the other one is 4 sine 2n. So I just plugged in a value. I just plugged in an easy value where they have different, sine and cosine have different values. So I plugged in theta is 0. So if I plug theta and 0 into my original equation, 2 times theta is 0, so I get 4 cosine 0. The cosine of 0 is 1, so I get 4 times 1, and that equals 4. So when the radius is 4, so I get the point 4, 0. So if I look over here on my graph, here's the point 4, 0, because it tells me what the dimensions of my graph are here. And on this graph, 4, 0 is like somewhere over here. So again, not on the graph. So it's got to be B. So just use the information we already have, and then you've got to use your notes. I've got to know this stuff about rose curves and how to figure out how many petals it has. Okay, next. For what values of theta between 0 to 2 pi do maximum R values occur on this graph? Okay, so when I look at this, max R, and again, I got this from my notes, is A plus B, where A and B are positive numbers. So I'm not going to use this -3 here. Okay, I'm just going to use 3. So my max is 4 plus 3, or 7. Okay, so in order for this to be 7, I need 4, and I need it to be plus 3. So how can I have -3 sine of 3 theta equal to positive 3 if the sine of 3 theta is -1? So where does the sine of 3 theta equal -1? So the sine is -1 at 3 pi over 2. Think about your unit circle, so that's down here at 3 pi over 2. So why did I put 2 more values here in my angles? So here's my 3 pi over 2. So where did I get these other 2? Well, since this is 3 theta instead of just theta, if I want to go from 0 to 2 pi, I'm going to have to go around, all the way around my unit circle at least 3 times. So here's one, okay? So if I go all the way around again, I'm going to add 2 pi to 3 pi over 2. And 2 pi is the same as 4 pi over 2, giving me 7 pi over 2, my second value here. And then if I go all the way around the circle again, I add 4 pi over 2 to 7 pi over 2, I get 11 pi over 2. And then finally, to get my answers, if 3 pi over 2, if 3 theta is 3 pi over 2, if I divide both sides by 3, I just get theta is pi over 2. And I did the same thing with the other two, and I simplified. And so the answer is A. Okay? Okay, let's look at the next problem. Determine which equation belongs to this Lima-Kahn curve. So again, this is a different kind of curve. There were multiple different kinds of curves presented here. You just go and look at your notes and find that. So what I notice about this, because some of them did this kind of thing, some of them just had like a dimple, some of them overlapped. This one looks to be concave. So in order for it to be concave, again, I got this from my notes, A over B has to be greater than 2. So remember, A and B are positive. So in answer choice A, 3 divided by 2 is not greater than 2. In answer choice B, 3 divided by 1, that's greater than 2. C, 3 divided by 1, that's greater than 2. And remember, I'm getting these A's and B's. R is A plus or minus B, and then either sine or cosine, it doesn't matter, theta. So that's my A and B. And again, they're both positive numbers. So answer choice D, 2 divided by 2, and I left out the no there, that is not greater than 1. So it's one of these two. So now we just have to figure out, is this a cosine graph or is this a sine graph? So cosine is symmetric about the x-axis, sine is symmetric about the y-axis. This is symmetric about the x-axis. Whoa. So that means this is a cosine graph, and so the answer is C, because B is a sine graph. That's really the only difference. Okay? Last one. The graph of r equals 2 cosine 5 theta is symmetric about what? Again, there's a lot of symmetry in here. Okay, so it's cosine. So I know that cosine is symmetric about the x-axis. So it's not going to be this one, and it's not going to be this one. And really, it can't be this one either. But what I do need to know is that if n is even, then my graph is symmetric about all three: x-axis, y-axis, and origin. But in this case, n is 5, which is odd. So it's not symmetric about all three. It's only symmetric about the x-axis because it is cosine. Okay, so that's all I got for you today on graphs of polar equations. Polar stuff, it's a little weird. It's one of those things that it's a shift in the way that we've been used to thinking about things. We shift it yet again. But the good news is that this is, we're almost done with polar, and sequences and series is just a whole bunch of formulas. So once we get the formulas, and that's our last unit, then we'll have that, and then we'll be done. So thank you for coming and checking this out, and I hope it helped.